Okay, so this second question on the quiz has to do with trig integration. And here are the problems, as you can see, A and B. So let's just get started on the first one. And alright, so we need our formulas for the trig identities, right? We're going to eventually make some kind of trig sub. So the mother identity is sine squared theta plus cosine squared theta equals 1. Okay, and alright, so now divide through by cosine and you get the one for secant and tangent. So divide everything by cosine. This becomes tan squared theta. This becomes cosine squared over cosine squared theta is 1, and this becomes secant theta, secant squared theta. Alright, I'm still having that freezing problem. Okay, alright, so look at the stuff under the radical. So the point of trig substitution is just it's a trick for getting rid of the radical. So we want to recognize the thing under the radical as one of these trig identities, or something kind of close to one of those trig identities. So it's always just like there's a variable that's squared, and then there's a number. So then you have to recognize what form that gives, in terms of these identities. So if you have a square thing minus a number, this is kind of like, look what happens when I move this 1 over to the other side of this equation. You get tan squared theta is equal to secant squared theta minus 1. Right? Okay, so this matches. This is something square minus a number, and so that tells me to use this. So my substitution for A here is going to be x equals, so I basically want to do x equals secant theta, but because there's this 9 here, I'm going to put in 3 secant theta. Okay, and you'll see what happens with the 3, right? When we square, it'll become 9, and I can take it out of the radical. So I also have to figure out what dx cashes out to in terms of the new variable theta. So I just take the derivative of this. That gives me 3 secant theta tan theta. d theta. Okay. All right. So now I have a completely new integral. So let me copy everything over. So x has now become 3 secant theta, so on top I have the square root of 9 secant squared theta minus 9. Okay, that's a theta. And on the bottom here I have x cubed. So this is x now, so that gives me 27 is x cubed times secant cubed theta. Okay, and dx is this stuff now, which is 3 times secant theta, sorry about that, secant theta tan theta, d theta. Okay, alright, and so the radical is still here. We were supposed to get rid of it. So the way you get rid of it, first you take this 9 out. So let me just deal with that off to the side. So right now I have the square root of 9 secant squared theta minus 9. Okay, so some of you can probably just go right to the final result, but for those of you who've been dying to see the whole thing written out, it works like this. 9 times secant squared theta minus 1. Okay, so now I have, the square root of the product is the product of the square roots, assuming both things are positive, and both these things are positive. By things I mean this and this, right? So secant squared is always going to be, is that right? Secant squared is always going to be at least 1. Yeah, it is true, right? But just think about what secant is. So take this thing apart, and it becomes the square root of 9 times the square root of secant squared theta minus 1. Okay, and so now we can cash this out and as just 3, right? So this is just 3. And now look what we have here. This is secant squared theta minus 1, but this was our identity here, so that's just tan squared. So I have 3 times the square root of tan squared theta, and so this is just 3 times tan theta, because the square root of the square is just the thing. Okay. Alright, so let me go to this next stage and just replace all this stuff with what we just did. So we just saw that the numerator of this fraction is 3 times tangent theta. And a whole bunch of stuff is going to cancel now. So I have down here secant cubed theta, and now I have this stuff, 3 secant theta, go secant theta tan theta d theta. Alright, so just combine everything, right? So this secant is going to cancel with these secants, and this tangent is going to combine with this tangent. Okay, so after you do all that stuff, you get these 3's are going to make 9, and we're going to have tan squared on top, tan squared theta d theta, and on the bottom we're going to have 27 secant squared theta d theta. Oh, no, there's no d theta down there, sorry. Okay, so if you write out what these are, you know, tangent is sine over cosine and secant is 1 over cosine. This cancels down to just 9 over 27 of, whoops. Okay, so sorry, 9 over 27 is right, but I don't need that line anymore because this stuff has just become sine squared theta d theta. Alright, so you can see we're kind of closing in on an answer here. So this constant 9 over 27 is the same thing as 1/3. And this stuff is just sine squared theta d theta. Okay, so up here, and the statement of the problem, you can see somebody has anticipated that sine squared was going to show up. And can I copy that? I don't think so. But okay, so I'm gonna try something tricky. So this is theta over 2 minus 1/4 sine 2 theta, and forget about that constant. So I think I can capture this stuff. Let me see if I can cut it. Okay, great. And I can paste it down here where we need it. So put it there so I can copy it. Alright. So this stuff should be equal. Maybe, what am I doing? Should just put it there, right? Ha. Okay. So now this is equal to 1/3 times this. Okay, you say. Now it's a little bit irritating because now we have to go back to x. So let me draw the triangle. Maybe you aren't irritated yet because you can't see what's coming, but you will be irritated shortly. So here's the triangle. You know, this is the bonus game that you have to play when you do trig substitution. You draw the little triangle and draw theta. So here's theta. Alright, and we think back to the original substitution that we made. What was it? I don't even remember. It was days ago. X is equal to 3 secant theta. Alright, so that means that x over 3 is equal to secant theta, or, you know, secant is kind of weird, cosine scares me a lot less, so let's change this to 3 over x equals cosine theta, and I can do that because it's just taking the reciprocal of both sides. So remember, cosine is, what is it? It's adjacent over hypotenuse, so I can fill these in. And, alright, I'm going to wish that that thing was a little further over to the left, or that these things are a little further over to the right. Okay, so this must be, just by the Pythagorean Theorem, x squared minus 9. Alright, so what do we need to know? We need to know am I doing here? Okay, so I've got that stuff, that's fine. So I need to know what sine 2 theta is, and I need to know what theta is. So the problem with sine 2 theta is that this triangle is in terms of just 1 theta. So we could do some kind of geometry, and that actually sounds like fun. But maybe the easier thing to do is to use this formula, which I should have given you, but I guess you can look it up. Sine 2 theta is equal to 2 times sine theta cosine theta. Alright, so let me get some color in here. So for this thing, I can just use this, and that's what I'll do. The reason I'm doing this is because I can read these values off in terms of the triangle. So the triangle says that sine theta is, well, what's sine? Sine is opposite over hypotenuse, so sine is the square root of x squared minus 9 divided by x. And cosine is, actually cosine is right here, right? Here's cosine. Okay, so, alright, so I need to make some substitutions. Let me give myself another page. Not sure what just happened. Okay, so for some reason it just repeats. Okay, that's brilliant. Can I use this tool to push things up, I wonder? No. Okay, alright, so, sorry, maybe I can take this with me though. Just take all this stuff and let's go someplace where there's more space. Where is that going to be, you ask? I don't know. Well, here. Alright, let's try it there. Okay, so now I want to recopy this. This is what we're working with, so just to make sure everybody stays with me, I'm going to copy this stuff over and replace sine 2 theta with this stuff, which it's equal to. Okay, so let's do all that. So I've got 1/3 theta over 2 minus 1/4, and I'm replacing sine 2 theta with 2 sine theta cosine theta. Wonderful. And now I want to go back to x, so I can put this in for sine, and I can put this in for cosine. But what about stupid old theta? So for theta, I don't know. We can use this equation to figure out what theta is. So just apply inverse cosine to both sides. So inverse cosine of 3 over x is equal to theta. Okay, so now I have something for theta too. So that's going to be theta. Alright, so now finally we're going to be back in terms of x, if I can just manage to copy this line over. So I've got 1/3, and this has become cosine inverse, so this is inverse cosine, 3 over x, also known as arc cos. It's arc cosine, so I think I've been using that more frequently, but it's the same thing as arc cos. So the arc cos of 3x is also equal to theta, because these two things mean the same thing. And what else? So this, this 2 cancels with this 4 and becomes 1/2. And now for sine, I have this stuff. So square root of x squared minus 9 over x. And for cosine, I have this. Alright, and let's just give ourselves a great big plus c and call it a day with this problem. So here is the answer. Right. Okay, so I'm going to give myself another page, which is just the quiz again. I don't really like that, but okay, it's the way it works. Also, you've probably noticed that you have this advertisement up here. And I don't know. So I used to use Linux to do this, and I didn't get advertisements. I really don't like advertisements, but thank you for tolerating the advertisement for the time being. Let's look at this, the second one here, B. Alright, so let me remind you of or you should, pause the video and figure out what the substitution should be here. It's easier, yeah, okay, so you've got it, right? It's tangent. So go back up and look at the trig identities, or write your own trig identities. So x is going to be equal to, and so y, maybe I should at least copy it over. So remember that tan squared theta plus 1 is equal to secant squared theta. Okay, so what I have here is something squared plus a number, and I recognize that as being like this. Here's the thing squared plus the number, and I want to do x is equal to tan theta, except this is 16, so I put in a 4, because when this is squared I want it to be multiplied by 16 so that I can take it out. So I have x equals 4 tangent theta, and now dx is equal to 6, oh wait, no, I did the wrong thing. So dx is just the derivative of this stuff, so 4 secant squared theta. Okay, d theta. Alright, so now we have a completely new integral. I'm just going to ignore the limits until I get back to x at the end. So I have dx has become 4 secant squared theta d theta. And down here in the numerator, this has become the square root of 16 tangent squared theta plus 16. Alright. And now I have to, maybe I can, I'm going to cheat. Copy, paste. You just have to make a little change. It's not worth rewriting everything. Okay. So what changes here? Well, the 16 is going to come out. So, okay. So let me take out that 16, and when it comes out it's going to become a 4. Maybe I'll do this. So when that fraction splits apart, I get 16, square root of 16 times tan squared theta plus 1. And all I did is I factored out the 16. Why am I I don't know, if it's hard to know what your students know, you know what I mean? So all I'm doing is factoring out the 16. So ask me if you don't understand what that means. Now you have tan squared theta plus 1 here, and tan squared theta plus 1, and now the miracle which trig substitution is intended to do happens. So you've got secant squared and you've got the square root. So this stuff has just become the square root of secant squared theta. Okay, so see how this is just the same thing as the square root of secant squared theta? So in other words, it's just secant theta. Alright, so the stuff under the radical, this radical on the bottom right, is now square root of secant squared theta, which is otherwise known as secant theta. So let's do all that stuff. So 4 secant squared theta d theta. And on the bottom here I have 4. And this has become secant theta. Okay, and those 4's cancel. And there's some secants that cancel, and this is just the integral of secant theta d theta. Well, that is super fantastic, and so let me keep this and push all that other stuff down. So I imagine that we're going to be running out of space really soon. So let me push all this stuff down. Okay. Come on, cursor. And I'm going to paste this. All right. So you can see right there, I've already written what the integral of secant is, because it's, I don't know if you remember it, doing it in class, but maybe we got the impression in class that it's harder than it is because we were trying to figure out the integral of secant cubed, but secant is still hard, so Google it and figure out how to do it if you want. But I'm just going to go ahead and use this formula. So the integral of secant d theta is equal to, do I really have to copy it? I guess so. Natural log of secant theta plus tan theta Alright, and we're going to be, this is a definite integral. We have these numbers, so don't worry about the plus c. Now we need to draw the triangle and go back to the original variable, which was x. So here's the triangle. Okay, and let me give us a theta. Alright, and what was the original substitution? It was x equals 4 tangent theta, wasn't it? So this is the same thing as tan theta equals x over 4. I'm going to regret writing that there, aren't I? And okay, so I'll cut it. Or move it. I can just move it. I'll just move it over there. Okay, alright. I left the bar of the theta behind. There it is. So let's start labeling the sides. So if tangent theta is equal to x over 4 and tangent is opposite over adjacent, then this is x over 4. Okay, so now just by the Pythagorean theorem, this is going to be 6 squared root of 16 plus x squared. So just write out a squared plus b squared equals c squared and solve for the hypotenuse if this is a mystery. Okay, so what is I've got tangent here, so I can do that. I can do the tangent in terms of x, but what is secant? So secant is hypotenuse over adjacent. So secant theta is going to be the square root of 16 plus x squared over 4. Okay, all right. So now I'm trying to get back to x, and I'm going to be all right because I can put x over 4 in for that tangent theta thing, and I can put this stuff in terms of x in for this theta, and then I'll be back to x. So let me do that. So I've got the natural log of, now I've got the square root of 16 plus x squared over 4, and this tangent thing has become x over 4. And we still have the limits of integration that go from 0 to 3. Okay, so from 0 to 3. So what happens when you plug in 3 here? So this becomes 16 plus 9 is the square root of 25, which is 5. So 5 there over 4, and this becomes 3/4. Okay, and now we take away what happens when we plug in 0. So when we plug in 0 here, this becomes the square root of 16 over 4 is 1. And this becomes 0, so it's natural log of 1. And you probably know that the natural log of 1 is just 0. So the final answer is just the natural log, just this thing. And if you add 5/4 and 3/4, you get 8/4. And 8/4 is just 2. So natural log 2. That's the final answer. And that took 23.5 minutes. Alright, but we're done, and so that's it.